Our first speaker, guys, is Dr. Leila Hamdan. She's an associate professor of marine microbial ecology and interim associate director of the School of Ocean Science and Engineering at the University of Southern Mississippi.
Thank you, Aaron, for that introduction. As Aaron just said, I am Leila Hamdan. I am the interim associate director of the School of Ocean Science and Engineering at USM. And what that job means is that I have the privilege to support the work and science and innovation of about 90 students, staff, and professors that engage in study of the coast and the ocean. But I did not wake up one day and decide to be in this job. I think maybe Joe Griffith would probably say something similar along those lines. And you know, ending up in this position took a couple of decades, if you can believe that. A lot of twists and turns in my career, including a stint as several stints actually as a waitress. I've sold shoes. I was a laboratory technician, and an important part of my career before coming to a university was I was a federal scientist at the Naval Research Lab. And originally from a place called Paterson, New Jersey. This is a place that is among the top 10 most densely populated cities in the United States. A very urban area located just outside of New York City. And it's not a place where, as I once told, that ocean scientists are supposed to come from. And I've spent a good amount of my career challenging that idea and bringing in people into my lab from all walks of life, because I think that everybody should have the ability to be part of ocean science. And, I consider my career as an ocean scientist to be a very improbable but highly treasured gift. And it's a gift that's been given to me by teachers and mentors, and it's involved a lot of luck, but it's also taken a lot of hard work and personal responsibility. And I can't stress that part of things enough, that your careers are going to take a lot of hard work. But I can't also stress enough that that hard work is worth it, because I get to do a job that I feel like I was made to do. And every day that I'm in this job, I get to work with the most extraordinary and exciting people. So, that's one of my day jobs. But the other part of this, as Aaron alluded to, is I'm also a scientist in the field of microbial ecology. And I wanted to spend just a few short minutes telling you guys about what that the area of study is, and about some of the work that my lab does. And you just spent a few minutes watching a video of one of the historic shipwrecks that my research group studies. And this is a place that's found on the seafloor in the Gulf of Mexico at about 7,000 feet deep. And there are a lot of exciting microbes that we've been studying for a number of years. So we're studying marine microbial ecology. I'm guessing that this group of students probably has heard about this field, but not everybody has. And I love sharing more information about what we do. And what we do is we study the ecology of microbes in the ocean. And we're specifically studying the relationships with each other, but also the relationships with the environment. And in this field that is pretty technically challenging, we ask very basic questions. We ask who the microbes are through the lens of population genetics. We also ask what they're doing through the study of their metabolism. But importantly, we want to know why the organisms that are there, why they're there, and why they're doing the things that they're doing. And we use microbes in our research because they're everywhere. They are wonderfully diverse, both genetically and metabolically, and they have really short lifespans. And this means that they are living sensors of global and local change. And also importantly, they're significant to all life on Earth. And one of the parts of microbial ecology that my group studies is the built environment. This is a term that means, very simply, places or things that are made or modified by human beings. And we do find a lot of built structures in the ocean, And in the Gulf of Mexico, where I do a lot of my work, we see historic shipwrecks. We also see a tremendous amount of oil and gas infrastructure. And these places are important to study in general because they form the basis for artificial reef ecosystems, but they also help us expand our knowledge about life in the deep ocean. And some of the work that my group does is the biodiversity of microorganisms in the deep sea, but we also study preservation processes of shipwreck through looking at corrosion or wood degradation. So there's a lot of different areas of research in this field of microbial ecology. And I'm just going to show you two more cool videos because this is what I spend a lot of my work doing, is collecting cool videos of stuff in the deep ocean. And you're seeing these two videos. Up on the left, there's this very charismatic fish that's, bombing along in this video. We're trying to take a picture of something very specific there. On the bottom, there's corals. All throughout these pictures, you can see the visible things, the biodiversity of corals, of bivalves, of tube worms. But what our work studies are the things that you can't see. And I hope to impress upon you how important those invisible parts of the ocean really are, because they form the foundation for life in the sea through the process of chemosynthesis, that is producing chemical energy to support life, and also through putting down biofilms on things like shipwrecks that allow other organisms to settle. And I've told you some of the techniques we already use as molecular and microbial ecologists, but we work with geologists and physical scientists and engineers and computer scientists and archaeologists. And this is just my way of telling you that ocean science, it takes diversity of perspectives and people, it takes teamwork. And as your careers progress, I hope it involves some of you, and I can't wait to work with some of you as you enter careers in ocean science. So that's my 2 cents, and I'm gonna turn my screen back over. And if I have some time, I'd love to take some questions from all of you.
Thanks, Leila. Yeah, absolutely. If we do have a few minutes, if anybody wants to ask a question for her. We have Ireland Neville, if you want to go to Mike. And
yeah, thanks so much, by the way, for being on here. Your presentation was really good. I just have a few quick questions for you. So I guess the first one is, out of all the shipwrecks you've ever seen, which one would be your least favorite?
Cool question.
Which one would be your first favorite?
The least favorite is a shipwreck called Halo. I cursed.
Oh, that's my sister's name.
And I have a dog named Hilo. I thought it would work out great. The shipwreck it has a lot of relief, so that this one has structures and pipes and rigging that stand up about 20 to 30 feet from the seafloor, which when you're driving around it with a remotely operated vehicle on a tether, it is nothing short of terrifying, because the whole time you're moving around this thing, you have to keep looking back at it. It's a cable that connects a remotely operated vehicle to the ship, and you have to make sure that you don't get that cable wound up on stuff sticking out of the shipwreck, because if that happens, you can damage the shipwreck, but you can also greatly damage or destroy a remotely operated vehicle, which costs quite a lot of money. On top of that, there are high currents around this site, sometimes running at 2 to 3 knots, which is really fast for a little ROV that's about the size of a Mini Cooper, for it to stay in place and do the things that you want to do. And sometimes it just gets blown right off of the site. And also, we can't see the shipwreck, even though it's 400 feet long. We can't see it until we're practically as close as I am to my computer screen right now. So as culturally significant as it is, I'll be happy to never see that site again. My favorite one is a little shipwreck called Ewing Bank. You saw a picture of it or a video of it in this presentation. It's the one with all the corals around it. It's a place that it's beautiful. I'll go right there first off. It is a teal green color. It has covered with life. It is easy to work around. And every time we go to this place, I seem to end up thinking very philosophically about my science, but also coming up with tons of new ideas. What a cool question. I've never gotten that question before, and that was a lot of fun.
Thanks, Ireland. We'll go ahead with one more question. I think it's VJ Josephs is the name in the participants. If you want to go ahead and ask your question.
Okay, hello. What is the purpose of studying the real shipwrecks in order to determine the impact of the built environment on microbes, as opposed to taking samples of like metal or wood and submersing them in water in like a laboratory setting, in a sense, like just deploying, just like waiting and then later retrieving just samples of the material as opposed to the entire ship?
This is an incredibly thoughtful question, and I will tell you that we do both. So we do study the natural environments. We use these remotely operated vehicles to crawl around the seafloor and take sediment samples, to take water samples, but we also do place artificial reef structures. One of my doctoral students, she's studying how metal attracts biofilm on the seabed. And so she has constructed a series of experiments that we've placed where there are no shipwrecks present, but also very close to metal shipwrecks or oil and gas structures like oil derricks. And I have another master's student, Rachel Mosley, who's studying wooden environments and how wood provides a place for organisms to live and thrive and create biodiversity. And so she does the same thing. We study the wooden shipwrecks so that we know what happens in terms of biodiversity after something has been on the seabed for 200 years. But she also has engineered these wonderful experiments where we sink them to the seafloor, measure or allow them to sit there for either weeks or months, and then go back and recover them and see what had grown on them in that time. So our science includes both of those pieces, and it's really cool that you're able to think ahead and think about those questions even now in your career.